Howdy, 8th grade. Today we're going to be working on how to graph some rational functions. And whenever we see the word rational, I want us to pay attention to the part that says ratio. So a rational function is going to be a function that has a ratio in it, or really a fraction in it. So we're going to be looking at today how to graph these functions with ratios. And normally what these are going to look like, just as an example, would be something like y equals, let's do 5 over x minus 2 plus 3, which I know is kind of crazy. But we're going to look at this a little bit and be able to dig it apart so we can graph it. So I'm going to draw this graph real quick. Awesome. So this right here is kind of what this graph will look like. I made a slight error, which we'll look at in a second. That's okay. But what we notice about this graph is it's possible for me to draw two different lines on here that will never touch the graph. And I'll show you guys what those look like and where they are. So the first is going to be right there, and the second would be right here. So these are both going to go between the lines of the graph but never touch them. So this is what we call an asymptote. And an asymptote is going to be a line that our graph will get infinitely close to. So it will get infinitely close to, that means it's brushing up right against it. But it will never touch. Just imagine Gandalf right there saying, "You shall not pass," and then the Balrog sinks into the pit. And anyways, aside from the awesome Lord of the Rings bit right there, that's basically what an asymptote does, is it doesn't let this line pass it. So it's going to be very, very easy to draw these graphs if we make the asymptotes. So if we draw these asymptotes first, it's going to become very, very simple to be able to draw the graph, because I know that this line going over here is going to keep hugging my asymptote, and going down this way is going to keep hugging it as well. Going up here, keep hugging the asymptote, and going this way, keep hugging it as well. So once we know where the asymptotes are, it makes these really, really, really easy to graph. So it's all about being able to find the asymptotes. So we're going to have two different asymptotes, and they're going to be written as, one is going to be y equals something, and the other is going to be x equals something. And we're always going to have two. And I want to show you guys how to find them. So in general, I'm going to write out our equation for how our different graphs are going to look. So we could have y equals, and I'm going to put an a right here, divided by x minus b plus c. So if this is our graph, this is our general formula. General formula. Awesome. So what we can tell from this, I want us to look at it a little bit. So looking at it, we know that if b and x are the same, we have a problem. So these can't be the same, because then I would have x minus b is 0, and I'm doing a divided by 0. I can't do that, and because I can't divide by 0, x cannot equal b. X cannot equal b, which, guess what, is exactly what my asymptote is. It's something that x cannot equal. So my asymptote is at x equals b. Ta-da! That's pretty simple. So if we go up here to my example graph, we can see that we have x minus 2, and right at x equals 2 is where this asymptote goes. So at x equals 2, we have this asymptote because at the bottom we have x minus 2. Now let's think a little bit about where our y asymptote is going to be. So this is one of our answers right there. But I want to figure out where my y asymptote is. And if we look up at the graph, the y equals something asymptote is going to be the one that's going this way. And the one that's going this way, the line's going to get very, very close to when x is big, or over here when x is small. So let's try plugging in a really big x or a really small x and just kind of see what happens. So I'm going to have y equals a over, I'm going to pick an obnoxiously large x. We're going to use like a trillion. That's a million, billion, trillion, minus b. There we go, plus c. So at this point, compared to 1 trillion, whatever we have for b here is probably pretty tiny. So we're just going to ignore it, because b is way too small to matter. So I'm going to write too small. So we're going to ignore it completely, pretend like it's not there. So now I have a over a trillion. And how big do you think a number divided by a trillion is? If you said right now very, very, very small, you would be right. So this whole thing becomes puny. Very, very puny. This whole thing is basically 0. So what we're going to do is we're going to treat it like 0. We're going to get rid of it, and I end up with an asymptote at x equals, sorry, not x equals, y, if I get out of my eraser, y equals c. So my other asymptote is going to be where x is really big or x is really small. And if x is really big or really small, it basically takes this fraction and kills it and makes the whole thing 0. So we would end up with just y equals plus c. So my other asymptote is going to be at y equals c. So let's look at another quick example here. And if I have y equals 3 over x minus 5 plus 2, that means my asymptotes, well, my first one's going to be with this x and that 5, so I'd have x equals 5, and my second one would be y and 2, so I would have y equals 2. So if I want to graph this, I would start by putting a line at x equals 5, 1, 2, 3, 4, 5, and I know that's going to be one of my asymptotes, which we normally draw with dotted lines to kind of say this isn't actually part of the graph, this is just helping me graph it. And then I would put another line at y equals 2, which I'll put in right here. Right there, awesome. So I know that my line is going to be in 2 of these corners, I'm not quite sure which, and I know that we're going to have it kind of curving and touching the asymptote. So what I want to do is I want to pick numbers close to the asymptote for x and plug them in. So I have x minus 5, x is 5 is my asymptote, so I'm going to try x equals 6 and see what happens. So if I have y equals 3 over 6 minus 5 plus 2, all I did there was plug in 6 for x. That would be y equals 3 over 1 plus 2, or y equals 5. So when x is 6, which would be right here, y is 5, which would be up here somewhere. Let me pick a different color to actually graph with, right there. And let's try one more if I have x equals 4, because that's on the other side. So let's try x equals 4. I'll have y equals 3 over 6 minus, or sorry, not 6, 4 minus 5 plus 2, or 3 over negative 1 plus 2, negative 3 plus 2, which is negative 1. So now I have x is 4, y is negative 1 to put in. So x is 4 is right here, a y of negative 1 is right there. And from here I can get a pretty good idea of what my graph's going to look like. It's going to have to go through both these points and hug the asymptote. So one would be right there, and the other would be right there. And just like that, I am done graphing my rational function. So the big thing to remember is what an asymptote is. Please imagine Gandalf screaming at the Balrog. It'll make me very, very happy inside knowing that you guys are thinking about Lord of the Rings when we do these problems. And after we have the asymptotes, we just have to get a couple points so we know what corners we're going to draw in. Once we figure out what corners of this asymptotes we're going to do. Because sometimes we will get ones that go up this way and over here. We just didn't this time. Let me take those out. So we have to figure out what corners they go in. Once we figure that out, we're pretty much good to go. So make sure we do the lesson practice. Have a blessed day, and I'll see y'all in class.